Good morning, everybody. My name is James Anthony. I'm the Chief Technology Officer here at Inoapps, and welcome to today's webinar on Move and Improve with Cloud Infrastructure. Given the current coronavirus situation, I hope this webinar finds everybody safe and well at this point in time, but that does also ask me to ask for your forgiveness up front should you hear any children or dog-related noises in the background. Clearly, like everybody, I'm working from home. I have spoken to both sets, the dogs and the children, and asked that they be as well behaved as is possible and as quiet as possible when around my room. I suspect the dogs are going to be better behaved than the children, if anything. So let's get started. So opening up, I don't think this is a surprise to anybody. You know, what we hear all the time is it's all about cloud. You open any press, mainstream press as well as IT press, and this conversation is about migration to the cloud, whether that's on-prem, private cloud, whether that's public cloud, or whether that's some sort of hybrid mix between the two. And clearly you can see just from these and from probably your own reading that the spending on cloud is truly escalating. You know, we are very much into that wave. So surely the migration to cloud is a no-brainer. So let's get a starting point for today's conversation about how Move and Improve to the cloud would really work. So what we're going to talk about first is the fact that a lot of organizations or a lot of people, when they're looking at either migrating a system to the cloud or implementing a new system and contrasting cloud costs versus on-prem costs, what they might look at is the pure economics in terms of cost for a CPU hour, cost for a gigabyte of storage, whatever it may be, in one location versus the other. And I think that misses a lot of things, and we'll talk about what those things will be shortly. But also I would suggest that one of the things cloud has done over the last few years is forced systems vendors, hardware vendors, colo facilities, internal IT to be a lot more price competitive. You know, I used to work with one finance organization sticks out in my mind, that's for sure, where they used to get a cross charge of just over $40, I think, per gigabyte of what they call tier one storage per month. I think the days of that kind of internal cross charge have certainly disappeared, that's for sure. Cloud's keeping people honest when it comes to that. You have organizations who might have a line of business saying, well, I get charged £2,000 a month for hosting this server, but I can get the same server in the cloud for $1,000 a month. Therefore, the economics stack up. But for a lot of organizations, inside that $2,000 is the hardware cost, but there's also the cost of the data center, etc. They're having to man and power and cool and all of that kind of stuff. Well, actually, all that really happens in larger organizations is the moment some of the tenants leave, the costs get then, those fixed costs then get spread out across the remaining tenants in the organization, meaning actually the overall cost of providing IT probably goes up because we're paying for both the cloud costs and we're paying for the original data center as well. Now, the illustration you can see on the right-hand side is a simplified version of part of a proposal where we talked to a customer recently. And what we contrasted for them was deploying Oracle Standard Edition in a license-included model in the cloud versus actually buying some ODAs. So if you're familiar with Oracle, the Oracle Database Appliance, buying 3 of them, 3 environments in the cloud as well. There was a production, a non-production system, and a DR system. And these are the illustrative costs. So you can see there's a big incremental cost in year 1 for the on-prem solution, which is what you'd expect. We have to buy those 3 pieces of hardware. We have to buy the licenses that come from Oracle. But look how actually we're paying off inside 3 years. The economics flip, that the on-prem solution becomes cheaper than the cloud solution within 3 years. So if you have a hardware refresh cycle that expands over 4 or 5 years, you're potentially looking at this as a pure economic case, better off doing an on-premises deployment. And yes, this did include hosting costs and power and cooling costs, etc. as well. So that kind of leads us to think that, you know, we need to look beyond the economics. And that's one of the things we are always very clear of when we do our cloud transformation studies with customers, that we will quite clearly project the costs of doing these and contrast that to the equivalent on-prem solution. But once you start to take into the other factors we're going to talk about over the next few slides, I think the business case for cloud stacks up much more clearly from that side of things. Okay, so what do we mean by move and improve? And firstly, yes, I know that's a phrase a lot of people use glibly. So what do we mean by it from that side of things? Well, the value for me of moving to the cloud is how we improve our situation when we get there, quite clearly, quite obviously. And what does that mean? That could be the economic situation we've just talked about. It could be operational efficiencies. It could be performance. It could be our high availability and disaster recovery stance. What's the improve aspect of it? So we get a lot of organizations talk about cloud native. Now, if you've ever looked at the work the CNCF do, there are some really, really cool projects in there. Many projects I'm sure people will be familiar with. Many projects I'm sure that are totally alien to people right now in terms of what they do. But, is a move to a full cloud native architecture really something we can undertake? I think, a lot of the proponents, a lot of the organizations that talk about the benefits of going fully cloud native, actually the organizations that are most geared up for them. We can look enviously at what they do, but a lot of them are the newer organizations who don't have a legacy, perhaps don't use as much commercial off-the-shelf software. They are people who are born in the cloud, whose business is software. And is it really something we can re-architect to? Let's just use Netflix as an example. Great company, but very much an organization that suits the cloud really well. They have software as their business, and therefore they employ some of the brightest and best developers to do that software. But when it talks about timescales at the bottom of this slide, their migration to their cloud platform, their on-prem data centers, took them about 7 years, I believe, to go through. So there's a big timescale involved in doing that and the re-engineering that's required. And yes, we can talk about things like chaos engineering. If anyone's looked at things like the Chaos Monkey from Netflix, really great idea. You deploy this stuff as a distributed system across many cloud regions and many cloud availability zones, availability domains, whatever your terminology may be in your cloud provider. And you probably have microservices. So whereas coming from the sort of traditional world, if you like, that I do, where you have a database cluster with a DR copy of it, an application server cluster with load balancing, probably a web server tier in front of that, load balancers sitting in front of that, and you have a DR copy, or you perhaps span those application servers and web servers across sites. It's all an N-tier architecture, normally a sort of 3-tier architecture model from that side of things. And we could look at that and architect for high availability. That idea of chaos engineering, that suddenly we've gone to hundreds of servers, perhaps thousands of microservices spread across multiple regions and availability domains, all talking to one another in this interconnected fashion. How do we test the availability, the high availability and the disaster recovery of that? Well, let's just start randomly killing components of it. That would seem very alien to somebody like me, where yes, I'm pretty sure my database cluster will survive the loss of any given node, but I'm not going to just do it on a daily basis just to prove that is the case. So I think it's easy to look enviously at those sort of organizations who have got a full cloud native infrastructure, and perhaps for newer developments that suits really well. But we know most organizations have a raft of traditional software they want to move to the cloud, and they want to get value out of, whether that's reducing costs. And clearly we find ourselves in a situation with the coronavirus right now where a lot of organizations quite clearly are looking at reducing costs, but we also want to gain additional benefits, be that operational efficiency we talked about, security efficiencies, whatever else that may be as well. So for a lot of people, I don't think, and perhaps with the traditional environments I'm talking about, Oracle stack, moving to a full cloud native infrastructure. Oracle are on there, by the way. You'll find them in the top section under databases. If you look in the second column from the right under the databases, you'll see Oracle in the middle there somewhere. But actually, for a lot of organizations moving, the value is going to be in other areas than perhaps going through the full re-engineering to a cloud native architecture. So what might those areas be? I think what experience has taught us about those areas, about the improved phase, is they generally fall into 3 areas. The use of elasticity in the cloud. And for me, that was one of always the big things. If you looked at like the NIST definition back in the earlier days of cloud, that was one of the things they talked about, was the elasticity of cloud, being able to scale up, scale down, and pay just for what you use from that side of things to gain operational efficiency. And we've got some really good examples, and those of you with Oracle workloads, and we are talking largely about Oracle workloads today, I think there's some things that will stand out straight away when we talk about that. And performance gains, we'll go through it when we get to the slide, but we're talking about Moore's law coming into play here, coming to the most modern architectures we can with cloud providers who can build an architecture inside their data centers, both from a storage and a networking layer, etc., that we perhaps couldn't do on-prem without significant investment, being able to gain the advantages they provide. Now, one of the things I'm going to come back to on the last slide, and we'll talk about later on, is that we can often stack these up to get further economic gains through a possible reevaluation of our license estate when we're there as well. So let's come back to that later on. So let's take a look at this concept of elasticity. I think most people will be quite clearly familiar with it as one of the key values of any cloud solution, that we can scale up and then scale down based on the dynamic resource requirements. So the example I'm going to show over the next slide is of a hypothetical finance system that has quarterly requirements and an end of year requirement as well. And what we want to do is be able to burst up potentially for that. But that's a move and improve style approach. What happens if we look at just a pure lift and shift and we take what licenses we have currently on premises and move those in that bring your own license, BYOL model? Well, if we take our licenses that we have on-prem and take them into the cloud, we are limited in some ways by those licenses. So if we have 16 CPUs worth of processing power on-prem, and that's what we've paid for in terms of licenses, that's what we can deploy inside the cloud. And that may do two things. That may constrain us in the cloud, because actually 16 was maybe a compromise when we were on-prem. We probably needed 20 something, but we couldn't really afford it. But 16 gave us goodish sizing for peak. But all things being good, we'd like a little bit more processing power. But it also might mean we're paying too much when we're not in those peaks, because most systems are sized for the peak workload. But let's come back to that later on and let's look at the illustration. So what we're going to show here is just a sample illustration. Don't get too hung up on the costs. They will be clearly, your mileage will vary based on your systems. But obviously sometimes the bigger and more complex the solution, the principle still holds, but the economics can work out even better. So what we've got in this first one is an illustration based on bring your own license model, where we've sized for peak at 16. As I say, it wasn't necessarily what we needed, but it's what we could afford at the time. And you can see that in a cloud model, we're bringing them and we're just paying for the infrastructure that sits underneath it. And therefore, every month the cost is flat. What happens if we looked at an elastic model? With the elastic model, you can see what I'm doing here is during normal months where I'm not doing a quarter close or the close of the year, I really only need 4 CPUs. And that's what a lot of organizations find. Outside peak, and they've sized for peak, their requirements are much lower. And then at the end of every quarter, so Jan, July and October in these cases, what we do is we scale up, and we only really need 8 CPUs for that period, but we scale up there. And in our year end, which was what we sized for previously, I'm going up to 16. Now I could go up to more than that in this cloud environment if that's what I needed. And how I'm going to fund that is look at the baseline costs. In those off months where I don't need that processing power, my consumption is much lower, and therefore I'm saving money during those periods to allow me to scale up much higher in the periods I do need as well. So there's an opportunity to be able to use that elasticity and look at potentially refactoring how we use our licenses in the cloud, migrating to that license includer model to be able to burst up and down. And we'll talk about that as we go towards the end in the final couple of slides. Hopefully that gives you an illustration of why we see elasticity as being the major benefit. And as I say, bear in mind, it will allow us to burst beyond potentially the capacity we've got right now. One of the things we'll always include in any cloud managed service is this concept of right sizing, ensuring customers are only paying for what they need, especially where they're migrating off an on-premises solution and we might not necessarily know exactly what the footprint looks like in the cloud. Move to the cloud and then scale it up, or most importantly down in some cases to reduce our spend as we need it. And that right sizing concept that we do as part of our managed service is really critical for adding value to the project on an ongoing basis and looking at the system, not just when we first moved it, but clearly as it grows over time as well. Let's talk a little bit about the efficiencies of operation. And for me, this is the area the cloud provides us with the potential to get the most benefit from in that improved phase. I'm not saying that people don't have the capacity to automate and gain operational efficiencies in any deployment, wherever that is. That's absolutely typically the case. We can always think of areas we're looking to do that. But what we're talking about here is as we move from an on-premises solution and we move into the cloud, what are our options to leverage the PaaS services? So those platform services where the cloud provider takes on the administration, the patching and the management of it and provides us with an SLA. And therefore we can stop administering those ourselves and allow the cloud provider to do it. Now, clearly, if we're talking Oracle at the moment, a lot of focus is around autonomous database in particular. It's a fantastic product, something I'm not going to cover here today, but if it is something you're interested in, let us know. We've got lots of other material on that from our deployments and our own usage, etc. of it as well. But what if we aren't there right now? What if we have something like Oracle eBusiness Suite where we can't yet deploy that on the autonomous database? We want to move it to the cloud and we want to gain some operational efficiencies. And for me, I think one of the key areas we look at is those products that surround the core product, that provide services perhaps across a number of products we've got. And we use them to support the core product, so support eBiz or PeopleSoft or our own first-party application we've developed ourselves. So let's look at three specifically. So let's look at the whole single sign-on solution: Oracle Identity and Access Manager, Oracle Internet Directory, SOA for integration, and things like ETL tooling as well. They're two or three you should think about there. And for me, the key point is that actually all of those at the moment are being paid for. Now, yes, you can talk about the annual support costs, and that clearly is a cost, but that's not really in operational efficiencies. That's an economic thing. The cost from an operational efficiency is the management of all of these. These are all products we install and we manage and we patch. And that means we have a virtual machine typically. We have an operating system running on it. We have the software itself, and most of that software runs using the Oracle products. So it will have a database for a repository. It will probably use things like WebLogic, etc. as well. And we'll have had to design them for high availability, and we'll be having to do disaster recovery. We'll be having to manage them. We'll be having to patch them. And actually, if you look at things like the quarterly patches, we released our bulletin about the latest patch for April the other day. If you're not getting these and you want to, please let us know. We release those. And look at that bottom point: 51 middleware vulnerabilities, 80% of which can be remotely exploited without authentication. These are products sitting in that stack. So we're probably looking at least at quarterly patching of these. Perhaps we might do that every 6 months, but we should be looking at patching. We've got the management of them. And I think in many cases, in my personal view anyway, the overhead of the maintenance and management of these products was significant. In some ways, we'd think about them as being higher than the core product themselves. So if we can remove that, we can remove the maintenance, the management, the patching, and the security of them, and give that to a vendor, Oracle in this case, that provides us with a really good high-level SLA on it. So we're switching the model in terms of our operational efficiencies to pass the back-end load of all of this kind of stuff off to the cloud provider, consuming it as a service, and then we devote our resources delivering stuff that the business really cares about. Now, I always say, nobody thanks you for keeping the lights on, but they'll sure as hell kick you when the lights go off. In this case, we're moving things that aren't core to our business off to the cloud provider, dropping some of the support costs potentially around it, so there's a cost saving, but then the opportunity cost is we can go and focus on deliverables for the business instead. The final area I want to talk about is performance. So clearly when we're modernizing, in this case we're talking about cloud, but it's equally true in many cases if we're modernizing on-prem, Moore's law comes into play. We're talking about moving to the latest CPUs. If you're coming off of old CPUs from 4 or 5 years ago, you're clearly going to go to a more modern CPU architecture and get a benefit from that. For database workloads, actually the move to a cloud platform that's providing a very high level of I/O operations per second is very important. And you're coming off spinning disks, then the levels we can get in Oracle Cloud Infrastructure are just phenomenal. We're talking about 35,000 IOPS on a single volume, and around 500,000 per VM higher on bare metal. Those are astonishing numbers of IOPS if you're coming off a spinning disk where you might have been between sort of 75 to 150 IOPS per disk. Just think about those numbers. And we know database workloads are often bound by the IOPS. A database is a way to store data. We're putting it in IOPS, we're pulling it out IOPS. And yes, there will be caches to allow us to serve stuff out of memory, but there is no doubting that if you aren't on an NVMe SSD based infrastructure right now, moving to a cloud environment will give you a huge performance gain. And from the Oracle side of things, we're doing that at incredibly cheap economics as well. And the dollar value, we're talking about sort of 5 cents per gigabyte for that level of performance. That's just phenomenal. And we're moving to very fast network connections, allowing us to transfer data between systems at low latency and huge bandwidth. Think about the cloning operations you undertake. Think about moving data for data warehousing operations. All of those things are going to look faster. If you are doing REST calls, if you are doing data loads over networks, all of those things are going to increase as well. And I've always brought this, as we've talked through this session, back to software costs as well. Well, think about when you bought your licenses and if that gives you an opportunity as well. If you bought 16 cores worth of Oracle 3 or more years ago, because that's what you needed then, is that something you really need now? And therefore, do we have the opportunity to look at rationalizing the license estate as we move to the cloud as well? So something to think about, and I'm going to draw all of this back together in the last slide. And all of this leads us quite nicely into the ability to potentially optimize our license position as we move into any cloud environment. So as we talked about earlier, and I'm just going to sum this up, bring your own license can be very attractive and very simple, but it may well not optimize you as you move to the cloud. So the first thing we talked about is, do you really need everything you currently have? Now that could be every product you currently have, and I'll come back to that in a second. And it could be, do you really need all the CPUs you bought at the time, especially as perhaps you oversize things? Perhaps, as we talked about with the elasticity, we've got the opportunity to look at things differently and make some real savings there, but also with the ability to burst beyond and provide more capacity than we currently have. So do we need what we've bought? Did we size for peak, and is it idle at the time? Well, why don't we size for the baseline and then look at paying for the burst capacity as and when we need it? So that opportunity is available to us if we re-architect our licenses for the cloud as much as architecting our application for the cloud. And can we look at those PaaS services? And for me, that's been a major area working with customers. We've seen the most success and the most positive feedback around the cloud migration, removing some of the products out of the architectural stack and using the PaaS services. Now, I just gave a few examples around things like SOA and the identity and access management side, but that could be things like the autonomous database for a data warehousing, just allowing us to consume those as services. That also gives us the opportunity potentially to free up the annual support bills around those as well, which again helps us fund the cloud side of things. Now, as I probably alluded to earlier, I'm talking about all of this stuff and I'm involved in a lot of these projects with our guys, but in some ways going through that, what have we got? What do we need and how do we map that can be harder than just doing the pure technology migration and implementation. Moving a database, it really isn't that hard in a lot of cases these days. Moving e-business suite, we've done tens of those these days into a cloud environment. We've got that buttoned down, but making sure that the architecture is more elegant and fit to purpose and gives all of the advantages we want, that to me is the benefit. And that's where Inoapps can certainly help organizations. So before we open up for questions, I'll just say that one of the things we talked about as we've drawn all this together is that cloud re-architecture, optimization, transformation process we step through with customers to help make sure their journey to the cloud is the most successful thing. If that's something you're interested in, you can see the details here. Please fire us over an email or just get in contact. We'd be more than happy to help. So with that, I'll open up for questions. Okay, so let's go with the questions. Oh, we've got quite a few. Probably won't have time to get through them all, so I'll pick a bunch at random, and what we'll do is anybody else who asks questions, if I don't answer it, terribly sorry, but we will commit to getting back to you personally with the answer to anything you've asked. So let's go with one. Do you have some examples where you've moved customers to Oracle Cloud? Yeah, loads. So we've moved customers in everything from huge systems that contain Exadatas at the back end with Oracle E-Business Suite, Hyperion, Master Data Management, custom applications, etc., through to smaller organizations who've just got a little database in terms of the overall size, a few hundred gigabytes potentially, with an Apex app we've helped them develop. And that's the beauty of it, because we can match design patterns, and because there's so much stuff now in Oracle Cloud, it doesn't really matter whether it's just a single database, whether you're looking to just have your DR in the cloud, whether you're just looking to put test and dev in cloud, etc. as well. So there's all those things we can do. So yes, tons of examples. Can't think of any more specifics off the top of my head. So let's go with the next one. It's too risky to move our production system to the cloud. So what approach would you recommend for us to enable us to get some of the benefits you were talking about? Okay, so firstly, I would argue it potentially isn't too risky to move a production system to the cloud. And if you are worried about the risk side of moving things to the cloud, we have got another webinar coming up that talks all about how you can de-risk cloud migrations. So please do take a look at that, and we're producing a sort of bunch of content around it. So let's say you're not looking to move initially your production environment to it. Clearly things like DR, and DR is a great use case because we often talk about this terminology, a pilot-like DR model. When I talked on one of those earlier slides about that analysis where we got cost of cloud versus cost of doing it on premises, one of the things I said is there are 3 servers in there: prod, non-prod, and DR. And that DR server is largely going to be idle. And that's what we find with a lot of DR capacity. It's idle, but it still has to have enough punch to handle the system if you scale over to it. So you might have, an 8-core, 16-core, whatever they are, CPUs in there. And most of the time with something like DataGuard, you're just rolling forward on a single core. You don't need that processing power. And that's one of the beauties of having your DR in the cloud, that you can run a pilot-like model, scale it right back down to just enough process to keep that DataGuard ticking over. Then if you do ever invoke the DR and fail over, you just scale up as needed using that elasticity I talked about. So things like DR are good use cases, and because of that, think about things like user acceptance testing or stress test systems. You can have them scaled right down, or even quiesced and shut down, and then just scale them up and get them going and give them the power that's reflective of production that you need when you're doing your testing. And that was something people often struggled to justify, was the cost of a full-size non-prod test system. Now they can absolutely have that. So looking at the time, probably got time for one more, so I'll pick the inevitable question about security. Yeah, what about security? How can I ensure my data is protected? There are lots of things you can do when you move to the cloud, and I would always argue that moving to cloud should never compromise your security. If you start at the bottom layer with the cloud providers themselves, they have huge levels of security and security attestation around their data centers themselves. If you go up a tier from that, you'll find things like encryption at storage, encryption at transit, encryption at the VM level. They're all baked into the platforms these days. Now, going beyond that, you talk about firewalls, etc. Well, if you look at the advent of WAFs, web application firewalls, these are things that people perhaps haven't had the funds to go with themselves on-prem, that you can now deploy just as a service in the cloud. We have anomaly detection systems such as Elastic or the Oracle Management Cloud that look at the traffic and look at the activity and notify us around anomalies. If you look at Oracle Linux, using Oracle Ksplice, you can make sure you're applying those kernel security patches with zero downtime. I'm sure there's a whole heap of content we keep meaning to produce about that whole Linux patching with zero downtime for the security. It's just a fantastic piece of back-end tech that nobody really talks about too much. I think these are all things you can do. So my ultimate point is, I don't think we should ever sacrifice security when we go to the cloud. And actually, I would argue in many cases, by having to think about security and go through the design patterns that you need to do when you go into the cloud, actually you can improve your security posture, because you think about it fresh and you think about potential gaps, and you look at the raft of security services you can now use in the cloud and choose which ones are applicable to the environment you've got. So thank you very much for that. Probably don't have any time for any more questions now. Hope you've enjoyed today's webinar and found it useful. If you have asked a question and we haven't got back to you, as I say, or I haven't answered directly to you, we will get back to each of you individually with any answers that we haven't covered here. So thank you so much for listening and watching. Everybody stay safe and well. Thank you.